How'd you do? Did you get it? All right, number 6. Down to the bottom row. Of course, now math gets a little bit more intense. Confidence interval time. All right, make a confidence interval with a level of confidence of 98%, and the sample standard deviation is 0.9, n is 12, and x bar is 6.8. So the first thing you have to decide is what kind of confidence interval formula should I use? The choices are z, t, or like a p hat one. And this one's definitely a T, and you can tell because there's an S right there. You don't know the population standard deviation. So we're making one of these. It's TIE fighters. Alright, so the error is T sub C times S divided by the square root of n. To find T sub C, you're going to have to go on page A18. And figure that out. And remember, degree of freedom is 11, so that's 1 less than you would than the sample size. So if you look that up correctly, you find out that that z-score is 2.71, not z-score, t-score is 2.718, and then multiplied by our standard deviation of 0.9 and divided by the square root of 12. And that gives you a t-score of not a t-score, an error of 0.7. So the middle of my confidence interval is my mean, that's 6.8. And then I'm going to add 0.7 to one side, which is 7.5. And then I'll subtract 0.7 on this side, which gives me a confidence interval from 6.1 to 7.5. Okay. Isn't it nice you don't have to have all these formulas memorized? Wouldn't that be insane? All right, chapter 7, here we go. One sample hypothesis testing. By the way, I am putting on the Schoology, I'm putting on a list of all final topics that could be on the test tomorrow so that you know that you're all organized. So that will be done. Yeah, so that you just know exactly what could be on the test. So if you're thinking, okay, if I do this Jeopardy game, am I all prepared for the test? No. Mostly, though. Good job. But if you were to go through that list and make sure that you at least had notes on everything on that list, then you're going to be fine. Really. It's going to be 11 problems. You get to cross one of them off. You can't retake it, so it should be pretty easy. A medical researcher claims that 5% of children have asthma. The N is, they did a sample, and they did 250 children. They got a p-hat of 0.096, so apparently 9.6 of them had asthma. And then we're supposed to test that claim at alpha equals 0.05. So, my H sub O and my H sub A. Medical researcher claims that 5% have asthma. Alright, so basically they're saying that the proportion is 5%, and that's a claim. And then the opposite of that is that it's not equal to 0.5%, 0.05. So if I draw a quick bell curve, I've got 2 regions this time. It's the two-tailed hypothesis test. And now we've got to do a little bit of math. So this is definitely a proportion hypothesis test, and the formula for that, if you look it up, is z equals p hat minus p over the square root of pq divided by n. So first thing I need is my p hat, which is 0.096, and then we're going to subtract that from p, which is 0.05. Well, not subtract p. And then you take the square root of p and q, which is 0.05 and 0.95, and divide by n, which is 250. And that gets you z-score, and that z-score is 3.33. Okay, so we need to also figure out the rejection regions here. So if you look up on page A16, you're going to find out that the rejection regions, remember in that bottom corner they have rejection regions, is negative 1.96 and positive 1.96. And then 3.33, that hits like way out here. So that means that I am going to reject the null. And since the null is the claim, and I'm rejecting both, so I'm also going to reject the claim. That 5% of children have asthma. Apparently, more than that do, according to this sample. It's been so rainy today. I can hear it going forward again. Chapter 8, last one, that is math. Okay, so here we go. A scientist claims that that pneumonia causes weight loss in mice. Probably, yeah. At alpha equals 0.01, can you support her claim? Okay, so I listed all the data here, so you can pause right now and start to figure it out if you want to. The mice are across the top. There's 6 mice that they tested. The B means before, and the A means after, so they must have given them pneumonia in some way. And then that was their weight before and after. So, pause the video, give it a shot. Oop, my cat is out in the rain and yowling. She's so cold, but she loves being outside. Alright, so for this one, if you look up the formula, you find out that the formula is d bar minus mu sub d divided by s sub d divided by the square root of n. So those are the things we need. So the first thing we need is all of the differences. So we're going to take the before and subtract the after, which gives us 1.4. So that means that that mouse lost 1.4 ounces. And then this mouse lost 1 ounce. This mouse was 0.7 ounces, 1.4, 1.2, and 0.6. And then if you put those numbers, I guess you could do standard deviation the long way if you really want to. But if you put those numbers into your calculator, you can find out what the mean is, which is d bar. So d bar is 1.05, and the standard deviation is 0.34. We're also going to need to know, of course, our h sub o and h sub a. Alright, so the h sub o is that the difference is what? Well, let's see. They want to find out if it causes weight loss. So that means it should go down, which means that all of this is good. So I guess that the scientist wants to know if the difference is positive, right? Because that would be a weight loss. And then the other one is less than or equal to 0. So this is the claim down here this time. Alright, so if I start plugging stuff into my formula, I get 1.05 minus 0, which is the right there, divided by s sub d, 0.34, divided by the square root of n, which is 6. Okay, so then if I draw a quick little horrible, absolutely horrible one, this is a right-tailed test, and if I look up that t-score is what this is. So if I look up a t-score, it is 3.365 right there is my rejection region. Remember to do the degree of freedom, which in this case is 5, when you're looking it up on the table on A18. And then if I figure out this test statistic, I get 7.56, which is way off the charts over here, which means I am definitely going to reject the null. Also means I'm going to accept the claim, because if I reject the null, that means I'm accepting the claim. So I am accepting the fact that mice do indeed lose weight when they have pneumonia, which is just amazing to find out. Okay. So, down to the random question. Hooray! Last one! Alright, random question. Here we go. Today we're talking about insects, bugs. So the answer to all of these is a bug. And you get 200 points per question here. So every question up until now has been 600 points, but this one is 200 points per question. No Google. So you have to